Alright, so this is basic equation solving for trigonometric functions. We have an equation here, 2 cosine x minus radical 3 equals 0. And I want to remind you here, it's a powerful thing. You can always find the solution to an equation by simply graphing both sides of the equal sign. So if I graph the left-hand side and then graph the right-hand side, all I have to do is find out where these things are intersecting, and those are solutions. Alright, so for this particular problem, we want to find all the solutions between 0 and 2 pi. So I have a graph here set up, and in this graph you can see that the red line represents 2 cosine x minus radical 3. The blue line is y equals 0, which is just the x-axis. Where these two things intersect specifically between 0 and 2 pi are at pi over 6 and 11 pi over 6. So that's the graphical interpretation of the equation. Now we're going to go back and actually solve it algebraically and see if we can get those same answers. So the first thing I'm going to do is get the cosine of x by itself. So I'm going to start by adding a radical 3 to both sides. And then I'll go ahead and divide by 2. So what we have here is that the cosine of x, the cosine of some angle x, equals radical 3 over 2. Well, think about that for a second. The cosine of some angle equals radical 3 over 2. Well, I can find that angle pretty easily just through knowledge of the unit circle. At pi over 6, the ordered pair is radical 3 over 2 comma 1/2. So I know that the cosine of pi over 6, here's cosine sine, the cosine of pi over 6 is radical 3 over 2. So x equals pi over 6. However, there's another place where cosine is positive. Radical 3 over 2 is positive. In other words, there's another place where the x-coordinate, remember this is a triangle, there's another place where the x-coordinate is positive, and that happens in quadrant 4, down this way. Now that angle is going to be this angle right here. And that angle is going to be 11 pi over 6. You could think of it as 12 pi over 6 minus a reference angle here, which is just pi over 6. And that also is going to have a cosine value of positive radical 3 over 2. So I can say x equals pi over 6, and I can say x also equals 11 pi over 6. Now those are the angles specifically between 0 and 2 pi. Sometimes they're going to say find all of the angles, not just 0 and 2 pi, but find all of the angles. And so that's a little bit different. We're going to start with pi over 6, right? So there's my pi over 6 angle. But if I want to find another angle who also has a cosine of positive radical 3 over 2, from this pi over 6, I can add another 2 pi, right? So what that gives me is pi over 6 plus 2 pi, which is pi over 6 plus 12 pi over 6, so that's 13 pi over 6. So that would be a solution, 13 pi over 6. Well, I can do that again, right? Once I'm at 13 pi over 6, I can add another 2 pi coming around this way, right? Plus another 2 pi. So that would give me then 13 pi over 6, 13 pi over 6, plus an additional 2 pi, an additional 12 pi over 6, which is 25 pi over 6. Well, I can do this all day long, right? I can add another 2 pi to that, and add another 2 pi to that, and so on and so forth. So the way we represent this, if they said find all of the angles, not just some of the angles, but all of the angles that solves this equation, I can say, okay, well, x is going to start at pi over 6, and then I'm going to keep adding or subtracting 2 pi. So the way I show that is I'm going to say plus 2 pi k, where k is an integer. All right, so any integer. K could be 1, 2, 3, 4, 0, -1, -2, -3. All of these angles, pi over 6 plus 2 pi k, are going to end at pi over 6. Similarly, for 11 pi over 6, now that was in quadrant 4, I can do the same thing, plus 2 pi k, where again, k is going to be an integer. So there's a couple of different ways that you can represent the solutions for an equation.